Hello, ladies and gentlemen. Welcome to the portal. I welcome you with a video. Um, this video it will talk about the basics of chemistry. You know, it's sort of like revision from grade 11. Okay, so I'm aware that the topic of acids and bases requires you to have knowledge on how to calculate moles, concentration, and how to use stoichiometry, percent purity, percentage yield, and a percentage impurity. Okay, so hence I'm doing this video for those ones who don't understand how to calculate these things. Okay, guys. So I will start with amount. What we say is amount, and which is what moles. When they say amount, they're talking about moles. Okay. I'm not talking about rands. Like when I say the amount of sodium hydroxide, then inside I say moles. Okay, it means I'm talking about number of moles. So now we know from grade 10 that number of moles is calculated as given mass over molar mass, right? And we've also learned that from the formula of concentration, if you rearrange and make n subject of the formula, n is equals to concentration multiplied by the given volume. Okay, so also we know when we work with gases that the given volume divided by molar volume, okay, is equal to what? Molar is equal to number of moles. Okay, so also from grade 10 again, so number of atoms divided by Avogadro's number gives us what? Number of is it gives us moles. Yes, it gives us number of moles. Okay, so let's start with these things of moles. So uh all right, so now in this one of uh n is equals to m over m given mass over molar mass. How this is what this is called given mass, this is called molar mass. Okay, so now I have noticed that some of the learners still don't know how to calculate molar mass. So before you can do anything, molar mass, it's simple to calculate molar mass. Okay, so for example, if we have calcium carbonate and we want to calculate the molar mass of calcium carbonate, what are we going to do? We are going to check the periodic table and check the atomic mass of calcium, atomic mass of carbon, and that of oxygen, and we have to look at how many oxygens do we have here. Okay, so meaning here it will be atomic mass of calcium plus the atomic mass of carbon plus atomic mass of what? Of oxygen. But how many oxygens do we have? We have 3 oxygens, so 3 times oxygen. Okay, so then you go to your periodic table. Here's my periodic table. uh, Calcium is 40, it has a molar mass of 40. So then I come back, I say 40 and 40 grams per mole plus 12 grams per mole for carbon plus 3 times 16 grams per mole of oxygen. So that should give me around 100. Yes, so I get what? 100 grams per mole. So that is the molar mass of calcium carbonate. Okay, this is how you calculate molar mass. So now if they say uh, this is example 1, right? Calculate uh, the number of moles for a 1.2 gram sample of calcium carbonate. So calculate the number of moles of a 1.2 gram sample of calcium carbonate. So what did they give you? They gave you a given mass, which is the smaller than m, which is 1.2 gram. Okay, so and then what do you need? You need molar mass. Molar mass is the one that we have calculated here, which is 100 grams per mole. Okay, so now what does the formula say? The formula says given mass over molar mass. So now given mass is 1.2 grams, isn't it? And then molar mass is 100 grams per mole, right? Per mole. So it's similar to if I write it like this, okay, times 1 mole, okay, because here you can see the exponent is negative, so I can write it in this manner. So now I can see that G can cancel G, and then I'm left with what? With mole. So 1.2 divided by 100. How much am I going to have? I'm going to have 0.012 moles of what? Of calcium carbonate. Okay, this is how you calculate number of moles. Okay, guys. So let's look at example 2. Example 2. So and then let's say a solution of uh, calcium, a solution of calcium, not calcium carbonate. Let me say a solution of sodium hydroxide, right? A solution of sodium hydroxide of concentration 0,1 of concentration 0,1 mole per dm cubed, right? And volume uh, is 0.5 dm cubed, right? Is transferred into a container. Is transferred into a conical flask. Okay, this is just a statement, into a conical flask, right? So now calculate the number of moles of the solution, okay, of the solution. So now what are you given here? You are given concentration of 0,1 mole per dm cubed. What else are you given? You are given volume, okay, of 0,5 decimeter cube. So now what is the SI unit for volume? The SI unit for volume is dm cubed, which is that one. So now which formula are you going to use? When you answer this, you start by writing C is equals to N over V, okay, and then from there you rearrange it. When you cross multiply, V is going to multiply C, and then you have N is equals to CV. You see, so C is how much? Is 0,1 mole per dm cube, okay. So uh, multiplied by what? Multiplied by 0.5 dm cubed. So here is mole per dm cubed, here is dm cubed. So now what's going to happen? We will multiply the numbers together, 0.1 times 0.5. Okay, what do we have? So we have 0.05. So but what are the units? If you check, dm cubed per dm cubed multiply dm cubed. So when we multiply powers of the same base, what do? We add the exponent. So when we add -3 to 3, we get 0. So dm exponent 0 is what? Is 1. So we no longer have dm, we only have what? We only have mole. Okay, so dm cubed cancels per dm cubed, you see. So we have 0.05 moles. This is how you can calculate number of moles. And also, what if they give you the volume in cubic centimeters? So if given volume in cubic centimeters, what must you do? You must convert. Okay, you must convert it to decimeter cubed. How do you do that? So if you are given 20 cubic centimeters, you are going to convert it like this, right? You are going to say 20 dm cubed divided by 1000 cubic centimeters multiplied by what? By 1 dm cubed. This is how you are going to convert it. So cubic centimeter cancels cubic centimeter. Okay, so we are left with unit of what? Of 1 dm cubed. So we have 20 over 1000, which is 0.02 what? Dm cubed. Okay, so now you can use this and substitute it in CV. Okay, so always convert your volume. Okay, so another example where you can calculate moles. Okay, so for example, you are given um, a reaction, acid-base reaction, whereby you have sodium carbonate, or let's say you have a hydrogen carbonate, which is a what? A bicarbonate with what? With HCl. Okay, so bicarbonate reacted with HCl, giving us what? Giving us uh, carbonic acid plus what? Plus Cl minus. Notice that this is acid-base reaction, so this HCl is going to donate a proton to the carbonate, okay, and then the carbonate to form carbonic acid. But remember that this carbonic acid decomposes to form what? To form carbon dioxide plus water. Okay, so now this is what we call, yes, it's an acid base reaction, but it's also what we call gas forming reaction, because it forms gas. Okay, so it is what you call gas forming reaction. So now they say uh, if mm, if 1 mole of carbon dioxide, okay, all right, let me do this. Okay, so if let me start it, okay, like this. Sorry, during the acid base reaction, carbon dioxide, let me say, 10 milliliter, 10 cubic centimeter of carbon dioxide gas forms. During the acid base reaction, 10 cubic centimeter of carbon dioxide gas forms, right? Calculate the number of moles of carbon dioxide gas at standard temperature and pressure. Okay, so what are you going to do if they ask you this question? So here's what you're going to do. You're going to use this formula: N is equals to given volume over molar volume, right? So given volume is measured in what? In dm cubes, right? And this one is molar volume, is measured in what? Dm cubed per mole. You see, dm cubed per mole. So now at STP, we have to look at how much is molar volume at STP. So molar volume at STP, you check the data sheet at the back of your question paper. You can see here they say VM is 22.4 at STP. You see, it's what? It's molar gas volume at STP. Okay, it's 22.4 dm cubed per mole. Okay, so now what are we given? We are given that the volume, which is the given volume, is 10 cubic centimeter. But remember, our volume must be in dm cubes. Okay, our volume must be in decimeter cube. So because our volume is in decimeter cube, we must convert it, right? So we are going to say this volume divided by 1000, okay, multiply by 1 dm cube. So it's 1 dm cube divided by 1000 cubic centimeters. Okay, so that cubic centimeter will cancel cubic centimeter, isn't it? So now 10 divided by 1000, okay, how much do we have? We have 0.01 dm cube of carbon dioxide. Okay, so now the number of moles of carbon dioxide, how much do we have? We're going to have 0.01 dm cubed, okay, divided by the Vm at STP. How much is Vm at STP? Vm is what? Is 22.4 dm cubed per mole at STP. So we're going to put 22.4 dm cubed times 1 mole. Okay, so here we can see that dm cubed will cancel dm cube. Okay, so now we have 0.01 over 22.4. okay, how much do we have now? We have number of moles of 0.446. okay, 0.446 times 10 exponent -3 moles of what? Of carbon dioxide. Okay, this is how you calculate number of moles from given volume. Okay, so this is what you do. Some questions, they will give you carbon dioxide volume and expect you to calculate number of moles from that. Okay, so keep it in mind and know this. Okay, so now the other one that is not famous but they can ask you as well, right? This one it was done in what, in grade 10. So uh, they can say to you, calculate the number of moles of uh, 1000, not 1000, okay, let's say 1.03 times 10 to the power uh, 22. Yeah, okay, yeah, 22, the power 22 atoms. Okay, calculate the number of moles of 1.03 times 10 to the power 22 atoms of sodium ion. Okay, of sodium ion. So now what are you going to do? You say n is equals to number of atoms divided by Avogadro's number. Okay, so number of atoms, the unit is what? It's atoms. And then Na, the unit is what? Is atoms per mole. Okay, it's atoms per mole. So now you will notice this, right? When you write the number of atoms here, we will need to divide with what we call Avogadro's number. How much is Avogadro's number? Okay, 6.022 times 10 exponent 23. You don't have to remember that, you can check it here. Okay, there it is, per mole. So on the formula sheet it's just written per mole, so it's what quantity per mole, or what the units per mole. Maybe it's molecules per mole, or what people per mole, you see. So but now what are we talking about? We're talking about atoms. So in this time around it's going to be 0.6,02, right? 6,02 times 10 exponent 23 atoms per mole this time around. Okay, so now here we are going to substitute our given number of atoms, 1.03 times 10 exponent 22 over Avogadro's number. Okay, 23. So how much are we going to get? Okay, press your calculator. Over 6.02 times 10 exponent 23. Okay, so we are going to get 0.0171 moles of what? Of sodium ion. You see, so this is how you calculate number of moles using this three given, how many? 1, 2, 3, 4. Yeah, this 4 given formula. Okay, so yep, so now let me check the time. Okay, so it mustn't drag. Okay, so let's go to the concentration, right? Molar concentration. So you are required to know how to calculate concentration, because these are the easiest marks you can get in an acid-base question. Okay, concentration. So now concentration, we can calculate concentration from knowing number of moles and what and our volume. Okay, so we can use these two formulae to calculate concentration, or we can, if we combine these two formulae, we get C is equals to given mass over molar mass multiplied by volume. You see, so this formula, it's these two formulae combined. Okay, so it saves time with this one. So let's do an example. Okay, I will use both with one example. Okay, so now now it says learners weight 1.6 grams of sodium hydroxide pellets pellets, right? And what they want to prepare, a solution of 250 cubic centimeters. They want to prepare a solution of volume 250 cubic centimeters, right? This is a statement. Calculate the concentration. Calculate the concentration of the solution of sodium hydroxide. Okay, so now look at this. So now the learners have weighed I'm not so sure about the spelling, but yes, the learners weighed 1.6 gram of sodium hydroxide pellets, and then I think here should be, I think it should be like this. Yeah, so they have weighed 1.6 gram of sodium hydroxide pellets. They want to prepare a solution of volume 250 cubic centimeters. So calculate the concentration of the solution. Okay, so now let's start with this one, right? So what do we know? So we need to know how to calculate number of moles, isn't it? So number of moles is given mass over molar mass, right? So now given mass, we are given that our mass is 1.6 grams, isn't it? And then the molar mass of sodium hydroxide, when you calculate molar mass of sodium hydroxide, you get 40 grams per mole. I've already showed you how to calculate molar mass, okay? So it's not going to be a problem for you. So now gram cancels gram, okay? So now 1.6 over 40, okay? So how much are we having? We have 0.04 what moles of sodium hydroxide. Okay, so now the original question says that they wanted concentration, so concentration is moles per volume. So now on number of moles we have 0.04 divided by the volume. The volume is what? Is 250 cubic centimeters. It must be in decimeter cube. So that 250 cubic centimeters, we must convert it. How do we convert? We divide by 1000 cubic centimeters. We multiply by 1 dm cube, so that our units are in dm cube. So cubic centimeter cancels cubic centimeter. We are left with the unit of what? Of dm cube. So 250 divided by 1000, we have 0.25. Okay, 0.25 dm cube. Okay, so here we'll divide with 0.25 dm cube. Okay, so now 0.04 divided by 0.25, how much are we going to have? We're going to have a concentration of 0.16 what mole per decimeter cube. Okay, so now this will be 3 marks, around 3 marks. So here they would mark what these two formulae, they would count for 1. Okay, and then they would mark the correct formula. They would mark substitution of the moles and the volume. They would mark the answer and what, and the units. Okay, sometimes they can give you 4 marks. So, and this question is always asked. You are always asked to calculate concentration. Okay, so alternatively we can use this combined formula, which is C equals to given mass over molar mass times volume. Okay, so that given mass, we are, it's what, it's 1.6 gram, right? 1.6 grams. Okay, over molar mass. Molar mass 40 grams per mole, isn't it? Times volume. Volume is what, 0.25 decimeter cube. Okay, so now you will notice this. So here gram cancel gram, right? This one is per mole and it's on the denominator. If we put it to the numerator, it will be mole. Okay, so now on the numbers, 1.6 divided by 40 multiplied by 0.25, so it's what, the 0, okay, we have a technical error. Okay, sorry about that. That was a technical glitch that we had. Okay, so we have 0.16, what, we have 0.16 mole per decimeter cube. This decimeter cube goes up there to become per, and then when this mole goes up, becomes mole. Okay, so 0.16 mole per decimeter cube. So you can see that we have the same answer, but here with less effort. So 1, 2, 3, you have your 3 marks. You are done with concentration. So now you know how to calculate concentration. So we can return to what? We can return to stoichiometry. Okay, so as you have seen in grade 11, I'm not going to go very deep in stoichiometry. Okay, so I'm going to be a little bit faster. Okay, so now imagine that